When you think of cold, you might picture Pluto, or deep space, or the far edge of the universe where no light has ever touched. But what if I told you the coldest place we've ever discovered wasn't out there? It was created here, on Earth. And what happens in that frozen state might change the way we understand time, matter, and the very laws of reality. Let's start with what we thought was the coldest place in the universe. The Boomerang Nebula. 5,000 light-years away, a dying star is blasting out gas so fast, it's cooling faster than any natural structure ever observed. Its temperature? 1 Kelvin. That's just 1 degree above absolute zero. Absolute zero isn't just cold, it's the point where all atomic motion stops. And the Boomerang Nebula gets closer to that than even the cosmic microwave background, which means it's colder than space itself. But then, Earth stepped in. In a lab in Boulder, Colorado, physicists built something colder than anything in nature. Using a process called laser cooling, they fired perfectly calibrated lasers from all directions at a tiny cluster of atoms. Lasers don't just heat. When tuned just right, they slow atoms down. And in quantum physics, slowing motion equals lowering temperature. They brought those atoms to within a fraction of a billionth above absolute zero. That's colder than the Boomerang Nebula, colder than any black hole's edge, colder than the universe. At these extreme temperatures, matter starts to change. Particles collapse into the same quantum state. They lose individuality and form something called a bose-einstein condensate. It's not a solid, not a gas, it's a quantum soup. Atoms move in perfect harmony, like a single particle. Time appears to stretch. Light behaves differently. You're no longer just studying matter, you're touching the edges of physics itself. Some researchers believe, at this temperature, we can simulate conditions seconds after the Big Bang, or maybe discover new laws altogether. So what happens if we could freeze everything? Not just atoms, but systems, clocks, brains, time itself? Time flows because things change. If you stop motion, you stop change. If you stop change, do you stop time? Some physicists think the universe will end not in heat or fire, but in cold stillness. A future where all energy has run out, everything is uniform. No motion, no difference, no before or after, just silence. From distant nebulae to laser labs on Earth, we're not just chasing cold, we're chasing truth at the edge of the possible. The colder we get, the deeper we reach into the code of reality itself. If you've made it this far, you've officially entered the deeper layers of space and physics. Subscribe to Beyond Light Years for science that goes beyond headlines and into the unknown. And tell us in the comments, what would you freeze if time no longer mattered?